So in that last bit, we took a look at sands and what sands can tell us. So let's take a look at our carbonate rocks. So remember, carbonate rocks are the rocks that generally have calcite, aragonite, or dolomite, right? They have that CO3 ending on them. Remember, we can tell them apart easily from the other rocks because if we put hydrochloric acid on them, right, they're going to fizz up like crazy. Our carbonate rocks are either chemical or biochemical in origin. So if you remember biochemical, that means they're going to have fossils in them. And all of our carbonates form within the intrabasin, right? So they're forming inside of the basin. So that's pretty important there. Now, the most important thing about our carbonates, very specifically limestone, this is the one we're going to see the most common, is that these carbonate rocks only form in one environment. And that environment is going to be in coral reefs. Right? So, anywhere we see limestone, that tells us that was once a coral reef. That's how limestone forms. Now, what's interesting about that is when I say a coral reef, we have to realize that that's a very specific environment. Right? Coral reefs don't form anywhere, right? I'm from Chicago. We don't have coral reefs in Lake Michigan. It's too cold, right? We don't have coral reefs off the mouth of the Mississippi River because the river puts too much sediment in the water. So what's really interesting is when we see the rock limestone, it's actually telling us something very, very specific. So when I see limestone, I know that that rock formed in very warm water. It formed in a tropical climate where it was at least 30 degrees north to 30 degrees south of the equator. It was in very shallow water. That water was also clear, and it's clear because the algae that lives on the coral is photosynthetic, so it needs sunlight. That algae gives the coral oxygen, and in turn, the algae eats the coral's poop. So they've got a good friendship going on there. So again, anytime I see limestone, it's telling me something very specific about the environment. So where I grew up outside of Chicago, I fossil collected when I was a kid because I've always been a nerd. And we fossil collected in these huge limestone quarries. So that tells us that about 400 million years ago when that limestone formed, we were closer to the equator. Right? So definitely showing us that our continents change position over time, and we're going to see environments also change over time. Now let's talk about the sedimentary rock record in general. So when we talk about these rocks, we're talking about lithostratigraphic units. These are units that can be traced over a wide area. They're distinguishable from other rocks. Now, when we take a look at this, if you look at this picture down here, you notice, right, this whole section that sticks up is actually made up of one kind of rock. That's what we call a formation. So formation is where it's all composed of one type of rock. This is all sandstone here. Now, if you notice in there, you can see different layers, right? Well, that's what we call a bed, right? So beds are the smaller parts of a formation. So like I said, the important thing about a formation, here's the fancy terminology, so it's lithologically homogeneous. It's the same rock type. So as we go through the semester, we're going to talk about different formations, like when we start talking about the Grand Canyon. So again, realize that a formation is one unit of rock that's different from what's above it and different than what's below it. We can also define a rock by its facies. So facies is basically the fingerprint for that rock. So, right, the police would be able to identify me by looking at my fingerprint. I'd be able to identify an environment based on the facies. For example, right, if I see a sandstone, well, I know that sandstone either formed in a beach or a desert. That's its facies, right? So we have a different kind of rock for different environments. And that's actually really important because we're going to see, like I said, that the Earth has been drastically different over the last 4.6 billion years. And that's how we tell these different environments apart, is by actually looking at the rocks. So that's why I like to call this class Geology CSI.